That's eventually able to train, getting up to 86 overall. Okay, we are able to train, but the results are not great. Let's see what we have saved. So yeah, the date, time. We only have the image. Okay, if we close it, right, we have the confusion matrix. So a true label, predicted label. What do we have? We have true, non-seizures. Anyway, we have 5 and 3 false positives, false negatives. So false negative will be when it's when it's a non-seizure and the prediction is seizure, that's a false positive. So we have 3 false positives. And when we have seizures and the prediction is non-seizures, is a false negative, and we have 5 of those. So it's doing pretty well. Wait, and this is on why the numbers are so low. That's 30 images, and that's just based on, that's the validation or the test dataset, so that's fine. There's a false detection of my hand on my ear. Okay, so we have the confusion matrix. What else we have? We have the examples of actually where it went wrong. So we have the true label 1 but predicted 0. We have true label of 0 and predicted 1. So it's kind of nice. I don't know why the epochs make. Why did we change the batch size? Yeah, changing from 32 to 64, we're actually able to train. Yeah, the results are not extremely great. Right, so we have the accuracy loss, model accuracy, confusion matrix, misclassified images. We had some bad results before. Yeah, like this one. What happened to that one? So image size is the same, batch size 64, 30 epochs, initial learning, augmentation false, shuffling true. Yeah, what happened to that one? What happened to that one? Or is it similar to what we... Doesn't look similar. The learning is happening quicker. The learning is happening quicker. Why is that? Considering we have the same settings. Oh, in the training log, we need to save the settings of the current model. Why can't I scroll this page up, page down? Yeah, by the way, those are the results. Yeah, the average accuracy in the original paper was much higher. So I don't know. Are we able to replicate the results or not? That's the one of the questions. Yeah, we currently get to fairly high accuracy of the model, but from memory we had a higher learning rate with some different settings before. So a couple of things. First of all, in the log, for the training log, we would like to save all the current settings for the model. So for example, currently we are getting these results with the following settings. So we'd like to adjust the code to log the settings for the model. And also, can you check in the conversation above, when did we have higher performance? What was the best performance with what specific settings?
To enhance your current training log, the code can be adjusted to save all the settings used during the training session, including the batch size, epochs, learning rate, augmentation, and shuffling status. This will provide a clearer picture of the model's performance under specific conditions, which is crucial for replicating successful results and identifying optimal configurations. Best performance settings from previous runs. Upon reviewing the previous conversations, the best performance was achieved with the following settings. Test accuracy. 95.0%. Average training accuracy, around 89.99%. Average validation accuracy, approximately 93.67%. Average training loss, around 0.47. Average validation loss, approximately 0.37. Training time per epoch, 1.1 seconds. Model size, approximately 71.26 megabytes. Settings for the best performance. Batch size, 64, epochs, 30. Initial learning rate, 0.001, significantly impactful on the performance. Augmentation, false. Shuffling, true. These results suggest that higher batch sizes and an initial learning rate of 0.01 were particularly effective. In the high-performance runs, the consistency of settings, such as augmentation being off and shuffling enabled, was also maintained. Adjusting the code to log settings. You can modify your code to ensure the training log records all current model settings alongside the performance metrics. Here's how you can adjust the code snippet. 1. Add logging of model settings. Insert a section to capture and log the batch size, epochs, learning rate, augmentation, and shuffling status. 2. Update the log file output. Ensure that the log file includes these settings clearly alongside the performance metrics. Here's a sample adjustment to your log section.
Okay, so yeah, as I thought, we had a better performance to the model. By the way, we need some music, what's called meditation session break. It also helps you doing some stretching as well. So feel free to turn it into a product, by the way. Yeah, have a lot of product fans. So yeah, write a business plan for it, so on and so forth. You can get ChatGPT to do it, by the way.